For our last lesson, guys, for our last lesson, we're going to be talking about slopes and equations of lines for parallel and perpendicular. I'm sure you guys have seen this before. Right? Stop talking about the quiz. Stop. So this is a little reminder of stuff that you guys should already know. Right? Slope formula. Hopefully you guys know that already. Slope is rise or the run for your line. To find that algebraically, if you just have points, you subtract the y's in the top and the x's in the bottom. If you guys have a coordinate plane, you can just count. That's totally fine. But if they just give you points without them graphed on the coordinate plane, this is the formula you would use to find the slope. Also a reminder, horizontal lines have a slope of 0, and vertical lines have a undefined slope, and you guys are working with this. What? It doesn't matter what order they're in as long as it's consistent for both the x's and the y's. Alright, these are also significant, the different forms of equations, because you're going to be noticing for different questions, they're going to expect you to write the equation in different ways. So you guys do have to have these memorized. All the different ways you can write the equation of a line. We have the slope and intercept form, which means they're going to give you the slope and the intercept, and then you would write it like this. Right? Your point slope form, which means I have to give you a point and then a slope. Right? A point separate from the intercept is going to be not 0, comma something, but a more complicated point. And then you would have to make sure you plug them into the correct spot. This can be a little bit tricky for some students because there are 2 y's, but the one that you replace with the value from the point, 2 y's and 2 x's, you replace the y1 and x1 with the values from the point. The regular y and the regular x stay where they are. And then you have standard form, which you can only find by having either of these 2 first, and then you rearrange the terms. So we're going to be practicing how to write all 3 of those different forms of equations when we get to that part of the lesson. So you do have to remember what they look like and their names. So be sure you're okay with that. So we'll come back to that when we actually need it. But let's go ahead and jump right into talking about parallel lines. Ready, please stop now. Put your desk normal. All 4 lights on the ground, please. Right? Parallel lines, what do you know about the slopes of parallel lines? Equal. They're equal. Parallel lines have equal slopes. Right? And you can tell by counting, you can use the formula, they may give you the equation or just tell you right up what the slopes are. But if the slopes are going to be, if the slopes are the same, the lines are going to be parallel. A little note you guys want to pay attention to, if you have a bunch of vertical lines, what do you know about them? All vertical lines are parallel to each other, right? What about horizontal lines? They're all parallel to each other. What about one horizontal, one vertical? Perpendicular. And we're going to see that next in a little bit. But just keep that in mind that all vertical lines are parallel to each other and all horizontal lines are parallel to each other. So my first question is this diagram right here. Whenever I give you a picture, never, ever answer the question based on appearances. They may look to be parallel, but that doesn't mean that they are. I need mathematical proof. So the way that you're going to do that is tell me what the slope is. There are 2 ways. Since I gave you the points, you guys could do the plugging into the formula, blah, blah, blah. But because it's on a coordinate plane, what's an easier way to do it? Just count, right? Just rise or run. So I go up, 1, 2, 3, and then run 1, 2, 3, 4, 5, 6. So the direct application of that counting process gives me up 3 and over 6, but would I leave my slope written like this? No. You always simplify so it's in smallest fraction. Okay? So that's our top line. What about the bottom line? We go up 1 and over 2. So if the 2 lines have a slope of 1/2, what do you know about them? Equal. They're parallel, not equal. Alright, so they're parallel lines. Excuse me. And again, you guys can count if it's on a coordinate plane. What if I didn't give you a coordinate plane? What if I just said point A is this and point B is that, point C, point D? Just give you 4 points and I want to know. Well, rise or run is when you're counting, right? You would use the slope formula, yeah, the y1 minus y2, all that. So if I don't give you a coordinate plane, you would just plug them right into the formula and find the slope that way. All right, what about this line on the left? Hold on, what's the slope of the far left line? Since we're going down, if it's ever going down, it has a negative slope. So this would be -3/1. Or a -3, just go right, -3, that's fine. What about the one on the right? Yeah, it drops down 6 and goes over 1. So that has a slope of -6/1. Would those be parallel? No, they would not. Right, so pretty straightforward. You guys can count on a coordinate plane or use the formula if the picture is not provided. All right, next application we need to talk about is I'm going to give you a reference line, that's this over here, and I'm going to ask you to write a new equation, right? I'm going to write the equation of a line that has a y-intercept of 5 and is parallel to this kind of example line that we're using. There are two things you want to make sure you look for in the directions. You want to look for all of the new information they're telling you about the line. So for instance, what's the intercept? What's the point that it's going through? That kind of information. Look for that. Then also, make sure you underline whether they're looking for the parallel or the perpendicular. So that's a really easy word to skip over. And we're going to be learning both today. So underline the word parallel so you know what we're talking about. I have two different forms of the equation I want you to use. Why do I want to start with slope-intercept form? Why did I pick this one? Why would this be the most helpful form of the equation to use? There were 3 different forms of the equation of a line. Why is this one most helpful to begin with? Yeah, so you can't find standard first, obviously, right? We had 2 other options, point slope and slope intercept. Why did I want the slope intercept form? Yeah, because they gave you the intercept. Guys, the directions basically tell you which form of the line to use first. They said it has a y-intercept of blah, blah, blah. When you see y-intercept, that's indicating they want you to use slope intercept first. Okay? So that's where y equals mx plus b, so we can go straight into that. Y equals, you should always get that part right. Well, except for standard form, sorry. Ignore that. I was going a little bit too fast. So for the y equals, what would go directly after that? Right. Because I want this line to be parallel, it should have the same slope as our reference line. So I'm going to keep the slope the same, but then what comes after? Plus 5. Because the intercept is different than the original line that they gave us. They're giving us a new intercept of 5. Right, so everybody understand how I got that? Same slope because they're parallel, and then you apply the intercept. All right, now I want it to be in standard form. So remember, standard form is when you have the x term, then the y term equals, and then the constant without the variable. So I need the x to be on the other side of the equation now. It's negative already. It's already negative. So I'm going to add it over to the other side. I'm going to show my work up here. So I'm going to add the x term over here so it's on the right side. So then it becomes this. All right, but that is not the final answer for standard form. Now remember, this can't be a fraction. So how do I fix that? Times 2. So you guys can cancel out that fraction. So I would get just x and then plus 2y equals 10. So y-intercept. The y-intercept is 5. That's b from the y equals mx plus b. Is everybody good with that example? Whoops. What in the world? I'm trying to move that. All right, everybody good? Before we go on to this next one, do you guys remember what you call, if I said I had this equation and then I rewrote that equation right next to it, what's the relationship between those two lines? If I have this equation, and then I have another line with the exact same equation, what's the relationship between those two? I just showed you. They're the same line. Coinciding. Make sure you remember that word. When you have two lines that are right on top of each other, they're the exact same line with the same equation, you call those coinciding. I don't know if that'll show up, but in case it does, coinciding. Alright. Next up, write an equation of a line that passes through this point and is parallel to this reference line. Alright? So what would be the best form of the equation of a line to use with this particular set of information? Point slope. See how the question gave you a point? It gave you a point, so you're going to be using point slope form first. What? Thank you. All right. Listen, please. Try to make a point. You guys keep distracting me. The information provided in the question will tell you which form of the equation to start with. I still want you to write the others, right? But this is our foundation format based on what they've given us in the question. So I'm going to be using the point slope form, which is y minus y1 equals m times x minus x1, right? Make sure you remember that. Then you start plugging stuff in. So I have y minus what? 2. That 2 comes from the points. If you want to label it, you can. The x and the y values from the point. What would the slope be if I want this to be parallel? 2/3. It needs to stay the same. And then x plus 1. Because the x value is negative, when you subtract a negative number, a double negative becomes a positive, right? So this is the point slope form. If the directions that you guys have for the question say just to write point slope, you leave it like that. If the question goes on to say, I want a different, specific different type of equation, you have to keep going and simplify. So now I want you guys to write it in slope-intercept form. If they say just write it like this, you don't. We're going to, but if the directions just say to leave it like this, you do. So what would I do to write it in slope-intercept form? Distribute. Yep. So to write it in slope-intercept form, I need to have the y by itself and everything else simplified on the other side. So I distribute the 2/3 and then add the 2. Yes. Write it as an improper fraction. That's just algebra. Hopefully you guys know how to do that. Distribute, then add the 2. Right? So that's your slope-intercept form. Is everybody with me so far? Alright, now I need to write it in standard form. Again, I need the x, then the y, then the equal sign, then the number that doesn't have a variable. So what would I do first? Move the x over?
No. Because the x always has to be positive.
I understand that, but we can take care of that in a second. So, if I mean, you can do it whatever order you want, but I like this one. If you prefer that, that's cool. If not, you can remove the fraction or whatever first. Alright, so I take the 2/3 x and I shift it over to the other side so it's in front of the y, but I did have to subtract to do that. Now that we have this, you have to remember that this number has to be positive and cannot be a fraction. So what would I multiply everything by to cancel that out and fix our problem? Yes? -3. That's going to cancel out the fraction, so it just leaves the 2 behind, no more fraction. It's also going to get rid of the negative. So multiply everything by -3. Yes? Again, that shouldn't seem new, right? You should have been able to do that before in Algebra 1, right? So I'll be looking at the directions for which form. Look for which form of the line I want. If I do not specify, it's really up to you, right? If I don't specify which form of the equation to use the form that matches the information that's provided in the question. Okay? Everybody with me? Alright, next up, perpendicular. What do you know about the slopes of perpendicular lines? Opposite reciprocal. Opposite reciprocal.
Yeah, can you just say opposite?
No, because it's both.
Opposite.
There are two things you have to do. You change the sign and flip the fraction. If you miss one of those, then you're not getting the correct slope for perpendicular. You have two things that you need to do. So for example, if I start with 1/3, to find the perpendicular slope, I'm going to change the sign and flip the fraction. So it would be -3/1, or just -3. Right? What if I started with -3/4? It would become positive, and then you flip the fraction to become 4/3. What about this one? -5/1. Last one? 1/7. Remember that every whole number technically is over 1, so you can create that reciprocal. Alright, is everybody with me with the slopes for perpendicular?
Wait, our 1 and 3, it's -3/1.
This, our first example?
Yeah.
Yeah.
Okay, I just didn't see it.
Alright. So we're going to do the same thing that we did before, but now we're switching the word to perpendicular. So it's the same information, same lines, we're just switching this word right here. Well, thanks, technology. I appreciate it. Alright, so I want a y-intercept of 5 and perpendicular to this line right here. We're going to start with slope-intercept form. Again, they have provided the intercepts, we're using slope-intercept form. So it's y equals what?
1.5.
Oh.
2x plus 5.
Should be 2.
Oh, yeah.
2x. We're doing, that's, you have to make sure you read the entire question, then switch to perpendicular. So it needs to be the opposite reciprocal of the original slope. It started as -1/2, so it becomes +2. And then you have your +5 right there. So that was the intercept, right? For the slope-intercept form. What's standard form? Yes?
Negative.
-5.
So, say that one more time.
2x minus y equals -5.
Yep, that's right. That's correct. There are a couple steps you guys can use to get there. If you want to preserve the positivity of the x, you can subtract the y over here and then move the 5 to that side to shift things around where they're supposed to be. But ultimately, whatever route you guys take, you should end here. There are a couple different ways to get there. Positive 2x minus y equals -5. Does everybody agree? Do I need to show that, or are you guys okay with your foundation for algebra? Yes? Nobody's saying anything, so I'll zoom out.
Yes.
We're good? Alright. Next one. It's the same as before. I'm just switching to perpendicular. So what would the point slope form be? Anybody? Brody.
Y minus 2 equals -3/2.
Yep. Notice where it said perpendicular, so you're going to do the opposite reciprocal of 2/3, the original slope. Alright. If you guys do the work for this next one, distribute the -3/2. You're trying to get it to be in slope-intercept form. Distribute and then add 2. Does anybody know what that would be? Just doing some algebra here. Again, to go from point slope to slope intercept, you distribute, like I did here, and then you add the 2 over to get everything on the right side. Alright? And then lastly, how do I write this in standard form? Let's do like middle steps. If I just shifted the x over, what would it look like?
X plus y.
Right? Hopefully you should be able to get this far at least. You know that the x has to be on the left side in front of y. So we add this term over. But can this be a fraction? We're going to cancel out the denominator. Hold on to the 3, but cancel out the 2. Everybody agree? Yes? Everybody good? Yeah.
Is negative, but 3 to stay when it's divided. Oh, wait, never mind. I got it.
Everybody good with the first page? Alright. Alright, 2 more things you guys need to know how to do with this concept is be able to look at the equations of 2 lines and decide if they are perpendicular, parallel, or neither of those 2 things. And at the very bottom, I'm also going to give you an exercise on if I give you a line, can you find other points that would help create a line that would be parallel or perpendicular? Those are the last 2 things we're going to talk about. If lines are neither parallel nor perpendicular, there are 2 options for what kind of lines they are. What do you think they would be? We're not talking about things in different planes. We're talking about the same plane. For now, we're talking about things that are in the same plane. So if they're in the same plane and they're not perpendicular or parallel, how would you describe them? Again? They could be intersecting or coinciding. So we have 4 options really when you're talking about lines. They could be the exact same lines, they're coinciding. They could just be randomly crossing, right? At really no particular angle, really. That would be intersecting. If they cross at 90-degree angles, that's specifically perpendicular, and if they don't touch, that's parallel. So you have 4 different options. We're only talking about perpendicular and parallel specifically right now. So if it's neither of those 2 things, you just say neither. You don't have to specify whether they're coinciding or intersecting. Just say neither, okay? So all you need to do is take a look at their slopes and tell me what's going on. It's really that simple. So for this one right here, are they already solved for slope-intercept form? You can find the slope real easy. This one is positive 3, this one is negative 1/3. So that would be perpendicular. No work required, because it was already solved for you. If you can see their slopes, just go ahead and tell me what it is. So what's going on with this example right here? Are they both solved for a slope-intercept form right now? No. So when one or both of the lines are not solved into the y equals mx plus b form, you need to do that for me. All right? This is if you guys see this kind of question, I'm going to say show work. This is what I mean. You need to resolve the question or start the equation for y. You have to do that. So for this one, I would add the x over, push the 6 to the side, and add the x to the front, and then divide by 2. When you divide x by 2, please write it as 1/2 instead of x divided by 2, because the 1/2 is going to be more significant of a representation to help you answer the question. Does everybody see how I went from the standard form to the slope-intercept form mathematically? Yes? Add the x over, divide by 2. Write it as 1/2. Okay. So now compare the slopes. The top one is a slope of 1/2. The bottom one is a slope of negative 1/2. That would be neither. Right? A lot of people will accidentally say that it's perpendicular, but why is it not?
Because
They didn't do the reciprocal part. You have to do both together, the opposite and reciprocal together. Alright, I'm not going to bore you by standing at the board and doing this, but I'm sure you guys are capable of doing it yourself. So I want you to finish all of these examples, please. If you have to solve the equation into slope-intercept, do that first, and then decide whether they are parallel, perpendicular, or neither. I'll put the answers on the board in a few minutes so you can check. So go ahead and work through those examples.
I just you work for no reason.
It's not no reason.
It's perfectly no reason.
Yeah, it just can't be negative.
Because there's different points for different. Just in different spots. So
I don't know. Oh, wait, no.
For the going through part.
What? Wait, is this for the bottom? Like, it's cut off the top.
It cut off the top.
I was making sure because I was like, that didn't make sense.
I cut off the two that we've already done.
Perpendicular.
Those are the last six.
Neither parallel. Parallel. What do you mean?
I didn't see that.
I missed it.
I got a 6.
Oh, wait, never mind. You're right.
On the outer one. You don't want to stay out. I got 4
There's no distance.
Started with 6,000. I ended with 5,000. It was short.
Alright, does anybody have any questions on any of those? Listen, please. Ready?
Yes.
Make sure that you invest. Make sure you guys know that when you guys are working through this process, if you can simplify a fraction to find the slope, you have to. So I think there's like 1 or 2 of them where you get like 2/4 or 3/6 or something like that, you have to make sure you simplify the fraction to actually get the slope before you compare it with another one, or else you get tripped up with that process. All right, so everybody's okay with that idea? Hopefully. The last thing we're going to talk about, this is for sure going to show up on the SFL in some sort of format. They always do this, where they give you a line like this, and then they give you a random point off to the side, and they say, what's another point on this invisible line that we haven't shown you that would be parallel to the one provided, or perpendicular. So the way that you're going to approach this is just like what we did at the front of the lesson. You're going to find the slope of the line provided, you're going to mimic that over here to create the parallel, or you're going to use the opposite reciprocal to find the perpendicular. So it's just like we were doing before. So to begin with, you want to find the slope of the line provided. So what's the slope of this guy right here?
3/1, which is just 3.
You can write it as 3 or 3/1, whichever is most helpful for you visually. To find parallel points, and for the SFL, there are multiple different answers. So they could present this to you as a TEI question, where you click to graph, or the other most common option, the other option that they use most often, there we go, is to select multiple answers. And you guys know on the SFL, if you miss one, you get the entire question wrong. Right? So make sure you're really careful. So for this question, I just need one, but you guys can graph all of them and just write one down. So to find the answer, you just mimic the slope. So I go up through everyone, or you can go the opposite direction, like this. Any one of those points is an acceptable answer. So pick your favorite, write it down. Okay? I want you to graph them all, but just write one down. Okay? Now, for perpendicular, am I going to do the exact same thing?
No.
I have to change the slope. So what would the perpendicular slope be? Negative 1/3. So find that perpendicular slope, and then your next points are going to be based on that. All right, so for perpendicular, you would go down 1 and over 3. Or up 1 and left 3. That's the perpendicular. So again, I want you to graph all the options, but just write down one, your favorite. Is everybody with me on that process? Okay, I want you to do the same thing for this line and this line. I want you to graph all of the parallel points, but just write down your favorite, and then graph all the perpendicular points that would help you create that line, but just write down one that's your favorite. Do that for both of those 2 points. That's right.
I don't have enough space to go down.
For this, try to go this way. It may end up off the graph a little bit. It shouldn't go too far off the graph. Just a smidge. But that's okay. This is not what I was asking for. I want the points. And that's just like what you're going to line is points. As long as you draw the dots. As long as it's
I did it right though. This one is -3. I am not on the wrong line.
it goes down 3 and over 4.
Oh, they have.
It's like
No, it's like a whole
graph the points. You just make your favorite.
No, it's not. The one where you go. When you-
Are you, oh,
I put one thing. Just take a look. That's the whole street. Ball behind you.
I don't know why we do give any. You can help it. I don't want to help. And then, so those are the points. I go back right. Besides that quiz, the homeworks, and then but I didn't understand this.
All right. For this middle example, I want you guys to share out some points that are on the parallel. For the middle one, what are some points that would be on the parallel? 1, -6. It would be at the very bottom of the graph. That's a good one. And then you could also use one over here. It's like -7, 0. Slightly off the graph, but still valid. All right. What are some perpendicular ones? 0, 1. There are others. I want you guys to name out all the ones you graphed.
3, 5.
Okay, 3, 5. And then there was another one that was like right on the edge of the graph, just underneath the corner, that you could have also used if you wanted to. All right, what about this one?
I got stuck.
You got it stuck? The slope is up to and over 1, 2, 3, 4, 5. You mimic that for the parallel.
You guys will.
I did. I went up to and right 5. This one? You go down 3 and over 4. So you go down 3 and over 4. So it would be positive 4 over 3, you go up 4 and over 3. Anywho, what are the points over here that you guys would use?
No.
What's a parallel point? -3?
Oh, wait.
Alright, please do not talk. Stop saying words unless it's answer my question. I'm asking for you guys to check your answers on this. 4 or 5 would be one of them. There's another one in the other direction. -6, 1. So either of those will be fine. You need to have both of those graphed though. Okay? And what about the perpendicular? 1, -2. That's really the only one that fits on the graph. There's another one that's slightly below the graph down here at like 3, -7 or something like that. Right? Please make sure you graph all of the options. You only have to write down one of them when I'm asking for the answer. Right? But I want to see that you understand how to extrapolate all the rest of the points on the coordinate plane. Right? Any questions about any of that? Okay. Hold on.